Special glasses part 2. Fiberglass is another type of special glass. Such type of glass is used in textiles and it is used for reinforcing yarn. It can be spun into yarn, gathered into a mat and made into insulation. A great variety of other products can also be made with it. Fiberglass is nothing but molten glass which has been processed mechanically to a flexible thread of filament. A hot platinum nozzle filled with molten glass forces out the liquid in the form of a thin continuous thread, which is caught by a rapidly moving disc, and it gets converted into fiber through elongation and the twist which is given by the disc. Glass fiber is also known as staple fiber. It has an average length of 19 inches and has a diameter of about 0.0028 inches. Fiberglass is not brittle, it possesses high tensile strength. Fabrics made of glass fiber are bad conductors of heat and electricity and are non inflammable. Articles made of fiberglass are fireproof. Laminate glass. Laminate glass is another type of special glass. For manufacture of laminate glass, sheets of glass fabric are soaked in a solution of phenol formaldehyde and then they are placed one above the other. The laminated sheets are then allowed to cure under heat and pressure, as a result of which hard, light and strong laminated sheets are obtained. Besides sheets, tubes and other shapes can also be made. Laminate glass is used as a material of construction, weaponry and insulation because it is highly non-inflammable and insulating. Its most important properties are that it is shatterproof. It is shockproof and can withstand sudden changes of temperature and pressure without undergoing cracking. A bullet resistant laminated glass is also obtained by pressing together several layers of glass with vinyl resins in alternate layers. The thickness of bullet resistant laminated glass varies from 12.7 mm to 76.5 mm, and these glass are prepared for specific purposes. Next type of special glass is glass wool. Glass wool is obtained by the action of steam jets on dripping streams of molten glass down from small holes. The glass wool, which consists of innumerable tiny fine fibers formed in this manner, is carried away by a conveyor belt on which it is dropped. Glass wool is a fibrous wool like material composed of intermingled fine threads of filaments of glass and has a number of important properties. Most important of which are it is non combustible, it is fireproof, it has low electrical conductivity, it is heat proof, glass wool does not absorb moisture or water, glass wool is chemically resistant to a number of chemicals, glass wool has a low density, glass wool has low thermal conductivity, glass wool has high tensile strength, about 8 times that of steel. Glass wool is used for heat insulation purposes in ovens, motors, vacuum cleaners, roofs of houses, and in domestic appliances. It is also used in the filtration of corrosive liquids, acids, and alkalis because it is chemically resistant. It is also used for the manufacture of fiberglass by blending with plastic resins. Photosensitive glass. This is high alumina soda lime glass which is sensitive in the ultraviolet region. It can reproduce the object in live natural colors from ordinary black and white negative recorded in the visible region. The positive on the glass is developed by thermal treatment at 540 degree centigrade temperature. The desired photoactivity in the ultraviolet region can be obtained by mixture of high alumina soda lime glass with small amounts of copper oxide, sodium cyanide, tin oxide in appropriate amounts. A blue color is promoted by sodium cyanide in absence of tin oxide. In presence of tin oxide, an impression in red is observed. By manipulating the ingredients in glass, brown and yellow images can also be obtained. A potash alumina glass mixed with lithium silicon oxide, cerium and silver salts in appropriate proportions are also used as photosensitive glass. Photochromic glass. Photochromic glass have a large number of microscopic particles of silver halides trapped in three-dimensional silicate network in fixed concentration. On exposure to light, temporary color centers consisting of silver particles only are produced, and these add up quickly, producing total darkness. The intensity of darkness depends upon the concentration of silver. Because reversible darkening is controlled by the radiations in the ultraviolet region, quite abundant in daylight, the photo blackening does not occur markedly in the light in the night.